What is going on, guys? Welcome to Flash Tutorials, and this is a new series now. Let me just put the word out there that if you are not familiar with Unity 3D and how to program in C# inside of Unity 3D game engine, then this is not a place for you. Okay, now let's get started and let me tell you what we're gonna create in this series. Okay, so as you can see on your screen right now, that we're gonna create a perfect maze generator. Now, what a perfect maze generator is, basically, so a perfect maze generator is basically gonna generate perfect mazes automatically by taking some values as parameters and stuff. Okay, so yeah. Now I'm gonna show you a demo of what this product is gonna end up being looking. So yeah, also all the information that you're seeing on your screen right now is gonna be linked down below, so you guys can go ahead and check out this blog post, which is on my blog right now, and you can read all this tutorial stuff and all that. Okay, so let me show you the demo and then we'll talk later. Okay, so this is the web demo. The link is in the description. I'm saying that a lot. Okay, so the link is in the description of everything you need to have to take a look in the description box. Okay, so what we have over here is a demo. So I'm just gonna select some random values right here and gonna click on generate. Now, as you can see, it generates a maze automatically. Now it is a random maze, so if I keep on generating, this will generate random mazes, and these all are perfect mazes. Okay, now I'm going to tell you what perfect mazes is in a moment, but let's just test it out a bit more. Okay, so I'm just going to generate random sized edge mazes. I'm going to go ahead, generate the big one, and smalls. Okay, so as you can see, it works pretty damn fine, and yeah, so let's go and do that. And if you want to get this asset or this maze generator for your own project, and if you want to help me out with my financial problem a bit, you can go ahead and get this asset on the asset store. Yeah, link is in the description down below, so you guys can go ahead and check it out. So this is the asset on the asset store. Also, you can there are a lot of features that you can use. You can generate an editor, or you can use in-game triggers and stuff, and it generates beautiful mazes using an algorithm called Dfs, or depth first search. Okay, so also I go by the name on the asset store as the asset provider, just to let you know. Okay, so that's enough of talking. Okay, so what we're gonna do in this series is we're gonna create a perfect maze generator. Y'all already know what maze is, alright? So it is a network of past hedges designed as a puzzle through which one has to find a way. According to our friend Google, of course. I can't really say that kind of stuff out of my head. Yeah, okay, so this is what a maze is by definition, and you already know what a maze is. So what we're going to create is called a perfect maze. Now, a perfect maze doesn't have any inaccessible cells, any circular paths that that looks something like this. Okay, so this is not a perfect maze. This is not what we are going to create. As you can see, it has some inaccessible cells. So if your player is outside these 3 cells, it cannot access any of those 3 cells. So this is not a perfect maze. On the other hand, this maze is a perfect maze, because every cell is accessible, and also it is accessible from any point of any other point cell, or whatever you're gonna call it. Okay. Also, what we're gonna do is called Dfs Algorithm, or depth first search algorithm. So it is also at the bottom of this page, so you guys can go ahead and see how it works and stuff. But I'm gonna talk about the depth first search in the later videos, not right now. Today, what we're going to focus on creating is a closed grid of walls. Okay, so we're going to create this grid by putting in some values of rows and columns. Okay, so we're going to generate the number of cells based on those values. This have to be a closed grid, and all these square in this grid is a cell, and each cell has 4 walls. Okay, so if you take this cell for an example, it has 4 walls. One is on the north, east, west, and south. All right, so that's what the walls belong. That's how we need to remember the walls for each cell. Now we're not gonna remember any of the information right now. We will just gonna create this grid, and as you can see, each line in this grid from one segment to the other, or from one intersection to the other, is an independent wall. Is a totally separate wall. It is not in any way joined with other meshes. Okay, so we're gonna create this closed grid. Okay, all right, so yeah, let's get started with it, and yeah, let's do this. Okay, so I'm just gonna minimize this, and no, actually I'm gonna close it. Okay, now what I'm gonna do is I'm gonna launch Unity. Just click on it, and we're gonna create a new project. Okay, I'm gonna call it new folder, maze tuts. Sorry, maze tuts. Right, I'm gonna select the folder. We're not gonna import any of these packages because we don't need them. It's totally gonna be based on programming. So I'm just gonna click on create, and we'll wait. Okay, and now we're gonna create some of these. We're gonna create some of some folders. Okay, so I'm just going to create one folder. Let's call this one scenes. All right, create another. We're going to call it prefab. One more. I'm going to go scripts. We're going to save the scene, and we're going to name this one test scene. All right, okay, so we have scenes saved. Now what we're going to do is we're going to create a new game object, and we're going to call this one and we're going to create a primitive object, a cube. This is going to be our wall. Okay, now I'm going to resize this on the x-axis a bit. I'm going to go ahead and call it 0.15, so it's a really thin wall. All right, now what you're going to do is you're going to go ahead and rename this to wall. Go to prefabs folder and drag this wall inside that folder. So now you have a prefab right over here. Okay, so yeah, I'm going to delete this from the hierarchy, and what I'm going to do now is I'm going to go to the scripts folder. Now, there's one more thing we need to do. We're going to go ahead, and now you can attach these scripts that we're going to create in any of the game object, but for this testing purpose, I'm going to create an empty game object, and let's call this game object maze generator. All right, now what we're going to do is we're going to create a new script. So go into your scripts folder, create a C# script. Now we're going to call this script maze, and that's it. You're going to take this maze script and drag it onto the maze generator game object. So it is attached right over here. We're going to save this scene, and we're going to open this maze script, and we'll wait. Okay. Now we're going to create some variables. Now the first variable that I'm going to create is called, let's call this one wall. This is basically going to be a game object which we're going to hold our wall prefab. Okay. The next one is going to be public x size, and it is basically going to be a 5. I'm going to give it a default value of 5.0, and of course it is a integer, not a float, sorry. Okay, and we're going to create one more. Let's call it y size. All right, we'll create another variable, and it's going to be a float, and we're going to call it wall length. All right, it's going to be having a default value of 1.0 f. Okay, that's pretty much it. So I'm gonna save the scene. Right, so I'm just gonna make it bigger so that you can take a look at it clearly. Okay, so we have created a game object variable named wall, a float variable wall length, which have a default value of 1.0, X size and Y size, both of them have the value of 5.0. So X size is basically how many rows you want to have on the X axis, and how many rows you want on the Y axis. So basically these are column and rows values. Okay, that's what it means. Now if we go ahead and I'm sorry, there's something wrong. Oh yeah, I'm sorry, it is not a float, it is an integer. What am I doing? Okay, so this should be fixed by now. There you go. Now if I go ahead and if you look at it, if you click on maze generator and look at the maze component that we have just attached, we have a placeholder named wall. So we're gonna grab our wall prefab and drag it out over here. Now once you have put it in the placeholder, we're almost done with assigning the components to the script. Okay, so if you want to use a default game object over here, so you can go ahead and do this. So you're gonna go ahead and select the maze script, and on the game object section you're gonna select wall. So whenever you attach this script to any game object, it will automatically gonna have this prefab assigned. Okay, let's move on and let's create some more variables. Okay, now what we're going to do is we're going to create a new function, and we're going to call it create walls. All right, so this will going to create walls for us. We need to call this function from the start function, so that this can be called at the start of the game. So we're going to go create walls, and now this function will be called. Okay, now we need to create the walls for us. Okay, so yeah, let's get started. We're going to use for loops to create these walls. Okay, for loops. I'm going to use nested for loops, and two separate nested for loops, and you can do it inside one for loop, but that would be just too messed up, so I'm going to create two separate for loops for that. Okay, now the first thing that you need to do is you need to create you need to find the initial position of from where you're going to start. So what that initial position is, so I'm just going to go ahead and show you what it is. I'm just going to go. Okay, so this is a grid that we're going to create, and if you look at it, we're going to create this in the middle of the word. So the center one, the center cell is going to be at 0, 0, 0 on the vector 3 point. Okay, so we're going to get the position of this wall right here. Okay, so we're going to get the position of this wall for initial start, then we're going to draw all these walls like this. All right, so yeah, let's do this. So the first thing that you need to do is you need to create a private vector tree. You know what, I might have to access the initial position later on, so I'm just going to create it as a global variable, private vector tree, and this is gonna be our initial position. Okay, now let's find what the initial position is. So I'm just gonna go initial position equals new vector 3. All right, now what we're gonna do is we're gonna find the initial position. So on the x-axis we're gonna go x size, because that's the number of cells we're gonna access, and we're gonna divide it by 2 because we are on the center of the screen, and we're gonna add the length of the wall. So we're gonna go wall length, and by the way, I didn't tell you what wall length does. Okay, so hold on a second. Okay, so if you go ahead and check out, we have another variable called wall length. Now what this does is basically it is the value of the cube on the z-axis. Now what we're gonna do is we're gonna go ahead and take a look at like this from the top view. So we're gonna generate this as a 2D maze, but we're gonna generate it using how should I put this? We're going to generate it as a 2D maze, but we're going to use z-axis as our y-axis. Okay, so that's what it means. So x-axis is going to be x-axis, but the z-axis that we're going to use is going to be used as y-axis, because this is a 2D maze, not a 3D maze. If I want to create a 3D maze, which you can do with this maze generator, is I will use y-axis as the z maze, as it will add more floors to it. Okay. Now what I'm going to do is I'm going to go ahead and continue with my initial position variable, and we're going to divide this also by 2 so that we could find the left side of the initial position. Now we're going to go for the top position, so y-axis, on y-axis. So I'm going to put 0 because I'm probably not going to use any of this thing. I don't really need any value on the y-axis. Now we're going to put the z-axis value, which is basically negative y size, and let's divide it by 2, plus I'm going to add wall length by 2. Okay, I'm sorry. Okay, so this is our initial position. Now what we're going to do is I'm sorry. Okay, now this will gonna hold our initial position. So if I want to use for future users, I can do that. But I'm gonna use it in a private variable. So I'm just gonna go ahead and create a private vector 3. I'm gonna call it my position and set it equals to initial position. Okay. Now what I'm gonna do is I'm gonna calculate some of the things. Okay. So what I'm going to do, I don't know. I'm going to create a public variable, and you know what, I don't need a public variable, but a private variable. Private integer. Okay, call it x size. We're probably not going to use it though, but you know what, I'm not going to use it right now. I'm just going to go ahead and generate the walls. Alright, so now we need to create the for loops for our walls. Okay, so we're going to go, I'm going to add a little comment here. I'm going to go ahead and go for x-axis. Okay, so this is a for loop for x-axis, and we can create integer I, and I equals 0, and I should be smaller than y size. Alright, so we are going up every second, and we're gonna increment it every time we go down. Now we're gonna create one more nested loop, so it's gonna be for, and create integer j equals 0. J should be smaller than and equal to. Now I'm going to tell you why I'm adding equals to. Okay, so I'm going to go x size, and we're going to go ahead and go j plus plus. Okay, so why did I added the smaller than and equal to sign? It's because I need one extra wall than the values of the cells. Okay, so what I mean by that, if you go ahead and take a look at it over here, so if I want to create a one by one maze, so there would only be one cell, but there will be 2 walls on the x-axis, so there is always going to be one more than what the value of the walls, a value of the cells are. So that's why I added the equal to sign there. Okay, now let's get the new position that we're going to put our player on, the wall on. So we're going to go my position, and we're going to go ahead and go new vector 3. All right. And we're gonna go ahead and get our starting points and stuff. Okay, so yeah, let's do this. But let me think about how I'm gonna do it. Okay, should I create? Yes, let's do that. Okay, so we're gonna go initial position, and we're gonna add .ax plus go I times basically it's j times a wall length All right, and we're gonna minus this value from wall length by 2. Okay, now for the y-axis, what we're gonna do is we're gonna put it on 0.0f. We don't really need to mess with that. Okay, for the z-axis, which are we using as y-axis, we're gonna use this to we're gonna use the I value to put it put the position of every iteration. So let's do this. Okay, we're gonna go initial position dot z plus go j times wall length. Sorry, it's not j, it's I guess. So I times wall length. Okay, and we're gonna negative wall length by 2. Sorry, by 2. Okay, so this is my new position. Now what we're gonna do is we're gonna instantiate this object. So we're gonna go instantiate, which is basically instantiate is used to spawn the game object. So I'm just gonna go ahead and spawn this game object. I'm gonna go wall. Where I'm gonna spawn it? I'm gonna spawn it on my position. And what rotation is gonna have? I'm gonna give it a default rotation. This is quaternion.identity. So quaternion.identity. There you go. So if I go ahead and run this right now, I should have a bunch of walls. Okay, so there you go. A lot of walls right here. So it should have 5 lanes. So 1, 2, 3, 4, 5. And that's pretty much it. Now we're gonna do same for the y-axis. All right. So we're gonna do same for the y-axis. So we're gonna copy this whole code, and we're gonna go ahead and let's just go ahead and put a comment right here. We're gonna go for y-axis. For y-axis. Okay. Now this is same as I and j, but what we're gonna do is we're gonna remove this value. This is the x size value from here to put it right here, and we will also gonna have a game object, a new. I'm gonna go ahead and create a game object, private variable, game object, and we're gonna call this one a temporary wall, right? Now we're gonna go ahead and put this temporary wall over here. So we're gonna go temporary wall equals instantiate game object, and we're gonna go as game object. All right. So we're gonna spawn that game object and assign it to the temp wall variable. Now what we're gonna do is we're gonna rotate this 90 degrees. Okay. So yeah, let's just do this. Okay, so in order to rotate your spawned object, what you need to do is you're going to go ahead and go over here and type quaternion.Euler, and we're going to go ahead and put 0.0f, and we're going to rotate it on y-axis. Is going to be 90.0f, and z is going to be 0.0f. We're not going to mess with the z-axis, and the x-axis. We're just going to rotate it on the y-axis. Okay. So once you have done that, save it, and you're gonna go back right over here, and if you run it right now, okay, so we will have this right here, but there is a problem, and this is not working very well. We need to set the new initial position for these objects. Okay, so we're gonna go back right over here, and we're gonna change some values on the initial position, my position variable right over here. Okay, so what we're gonna do over here is we are basically gonna go ahead and change some values, and this is gonna have is I guess initial position dot x plus cable outline is not gonna have by 2 because we will gonna put it at the bottom of the initial position, so it's not gonna have divided by 2. And I think we're done. But let's just test it out. Okay. Okay, I need to put it on in over here. Sorry, right over here. Run it one more time. Let's see what's gonna happen. Okay, I need to put all these values up ahead. Okay, I guess I found, I don't think the wall end should be here because it will just gonna take it back one wall. So let's just test it out. It should work fine now. Okay, so yeah, it creates walls and stuff, and let's just put some more parameters and test it out. We're gonna create a 10 by 10 grid. Let's see. Okay, so it works. I guess it works damn fine. I'm gonna go ahead and do 7 by 3. Let's see how it works. Okay, it is working damn fine. I'm very satisfied with it. Let's just do one more thing, because if we run it right now, you can see it creates a lot of clones in the game object in the hierarchy, and that will just gonna create a lot of mess for us. Okay, so we're gonna do one last thing to fix this problem up, and we're gonna create a game object. Okay, so we're gonna go ahead and create that game object. We're gonna call it let's say, you know what, I'm gonna go ahead and private game object wall holder. All right, and we're gonna go ahead and go over here, go wall holder equals new game object. Okay, wall holder, oh my god, okay, wall holder name equals, I'm just gonna call it maze because it is holding our maze in there. Alright, so that's pretty much it. I'm gonna assign it right here, so I'm just gonna go ahead and type temp wall right over here, and we're gonna call it as game object. Alright, now we're gonna go ahead and assign this temp wall as a child of wall holder. So we're gonna go ahead and go temp wall dot parent, sorry, transform dot parent equals wall holder dot transform. Okay, and that's pretty much it. I'm gonna copy it and paste it over here. So I guess this should fix the problem. Now all the game objects should be inside the wall holder or maze right here. Okay, so yeah, that's pretty much it, and it works damn fine. It creates exactly the amount of cells I need. Let's just test it out one last time. I'm going to create let's just say 4 by 7. Just click on play. Okay, it works damn fine, I guess. 1 2 3 4 1 2 3 4 5 6 7. It works very smooth, very fine. Now in the next episode, what we're gonna do is we're gonna assign, we're gonna create a custom class, and we're gonna assign the values to classes, and those and oh my god, I can't say anything. Okay, we're basically gonna create custom classes, and that classes will gonna hold information for our cells. Those that information is gonna be which wall belong to which cell and on in which direction that wall is. So these are some information that we're gonna assign to our cell classes in the next episode. Till then, goodbye, and I'll see you all later. And yeah, goodbye.